Hello guys, in the previous video we managed to solve the day 10 of Advent of Code 2024, and in this video let's continue with the day 11. So without further ado, let's jump to the day 11 challenge. Day 11, Plutonian Pebbles. The ancient civilization of Pluto was known for its ability to manipulate space-time. And while the historians explored their infinite corridors, you have noticed a strange set of physics-defying stones. At first glance, they seem like normal stones. They are arranged in a perfectly straight line, and each stone has a number engraved on it. The strange part is that every time you blink, the stones change. Sometimes the number engraved on the stone changes, other times a stone might split in two, causing all the other stones to shift over a bit to make room in their perfectly straight line. As you observe them for a while, you find that the stones have a consistent behavior. Every time you blink, the stones each simultaneously change according to the first applicable rule in this list. If the stone is engraved with the number 0, it is replaced by a stone engraved with number 1. If the stone is engraved with number that has an even number of digits, it is replaced by 2 stones. The left half of the digits are engraved on the new left stone, and the right half of the digits are engraved on the new right stone. The new numbers don't keep extra leading zeros. 1000 would become stone 10 and 0. Okay. If none of the other rules apply, the stone is replaced by a new stone. The old stone number multiplied by 2024 is engraved on the new stone. Okay. No matter how the stones change, their order is preserved and they stay on their perfectly straight line. How will the stones evolve if you keep blinking at them? You take a note of the number engraved on each stone in the line, your puzzle input. If you have an arrangement of 5 stones engraved with the numbers 0, 1, 10, 99 and 999, and you blink once, the stones transform as follows. The first stone 0 becomes stone marked 1. The second stone 1 is multiplied by 2024 to become 2024. The third stone 10 is split into stone marked 1 followed by a stone marked 0. The fourth stone 99 is split into 2 stones marked 9. The fifth stone is replaced by a stone marked with that. So 2,021,976. Okay. So after blink once, your 5 stones would become an arrangement of 7 stones engraved with the numbers these. Yes. Here is a longer example. Okay. In this example, after blinking 6 times, you would have 22 stones. After blinking 25 times, you would have 55,312 stones. Consider the arrangement of stones in front of you. How many stones will you have after blinking 25 times? Okay. Let's get the puzzle input, and we can say that this is the input, and we can split it by space, and at the same time I think we can get this test example input as well. Let's split it up and let's run this. And while we are waiting for the runtime to connect, we can think how we can solve this. So we have array of stones, and each blink will cause that we need to form or run these rules to each stone, check that if they are which one is the applicable one, and then form maybe a new list. So we wouldn't modify the current list, but instead create a brand new one. And basically do that for 25 times. Okay, so let's then start. Maybe we could create the stones first. Data class stone, and each stone has a number, which is basically integer. And I think that's all kind of, for now at least, what we need for the stone. So first we need to create the initial array, which is, for example, in for item in example input, we want to create the initial list, stones list, which starts, or we can actually do it like this, like in the same line. So if we will just do stone, stone, and then cast the item to be integer for item in example input. So now we should have the initial stone list, and if we check that one, we have 2 stones. Looks good. So then we need to apply the rules per stone. Apply rules, and then this gets the stone as an input, and this will return list of stones. So basically, idea which I had was that this apply rules will check which rule applies and then either return basically 1 stone with updated value, or the two stones because of the split that happens in one of these rules. So basically the first rule is if stone is encoded with 0, is 0, then we will return new stone with 1, and then the next one, if the stone is encoded with number that has an even number of digits. So basically we need to check if length of string of stone dot number modulo 2 equals 0. So if it has even number of digits, so basically if it has let's say 5 or 4 digits, so basically let's say 1500, we can actually even do the whole calculus here, then check 2, it should say true, yes, and if it's 15,000, false, correct. So then we can here say that the left half of the digits are engraved on the left stone. So basically we will return list of 2 stones, and we need to split then the number from the middle. So if we have that 1500 and then we calculate the midpoint, which is basically length string A divided by 2, and then actually we could technically do it like this even, and then get the first part, which is basically A until midpoint, and then the second part, which is starting from the midpoint to the end. And then we print this. Need to do it like this. True. So we have then 15 and 0. Yes. And we can actually do even so that we can cast these to be integers both, so that we can get the leading 0 issue solved. So then we get just 15 and 0. We can then just calculate the midpoint, stone.number, and calculate these as well, instead of using the A. Let's use the stone number, and then we can just give these as parameters. Yes. And the right half of these are engraved on the new right stone. Yes. If none of the other rules apply, the stone is replaced by a new stone, the old stone number multiplied by 2024. Okay. Then we have an else where return new stone. And it's the stone.number times 2024. Yes. So this should work already. And then if we do the test, so we would like to run it 25 times for underscore in range 25. Then what we want to do is that we want to loop through the stones for stone in initial stone list. And actually before that we want to also create the temporary array, or basically new stone array, which is initial stone list. Yes. And then we can just loop it through, and then have a temp stone list. Let's actually call it this list as well, which is empty, and that will be reset every time we initiate or start the new loop. And then in the end of every loop we need to update the new stone list. And here in this for loop we want to check, or first get the new stones from the apply rules function. And then for those we want to just add them into temp new stones. I think this should actually give us already quite good idea. And here we can print the temp stone. Or maybe not temp stones actually, but here we can check the new stone list. And if we run this, we get 175.17. Then 3 stones looks good. Then these are aligned as well. And if we check the end, maybe I want to print actually that iteration as well. So we can check it. So it runs 25 times. Yes, okay, looks good. And then in the end, we want to print length of new stone list. So how many stones we have there. 55,312. Looks good. I think we can now then proceed with the actual input that we got. So let's change that one. And then we can run this. Check that we have initial stones. Good, looks good. We can rerun this. And then for this, I think it's enough if we just print the iteration. So we can see a bit how it goes. And for this, it says that our result is 233,875. So let's try that out. Okay, that's good and correct. This was actually quite fast challenge. So far, at least this part 1. Interesting to see how the part goes, but I think it's good time to end the video here, so it won't be too long. And see you guys in the next part 2 video. See ya!